3a. The temperature T of water T minutes after being poured into a cup can be modeled by T equals T sub O e to the negative kt sub power, where T greater than or equal to 0, and TOK are positive constants. The water initially boiling at 100 degrees. When you say initially, which means T equals 0. When T equals 10, the temperature of the water is 70 degrees. Show that T sub O equals 100. Initially, which means T equals 0. The temperature is 100 degrees, so 100 equals T sub O e to the negative k times 0 power. So we get T sub O equals 100 because e to the 0 power equals 1. For 3b, show that k equals 1 over 10's natural log of 10 over 7. We know when T equals 10 minutes, the temperature of water is 70 degrees. Plug in 70 equals 100 times e negative k times 10. We need to solve this exponential equation. Isolate the exponential expressions on one side, so we divide it by 100 both sides. 7 over 10 equals e to the negative k times 10. Then we will take a natural log of both sides. Natural log of 7 over 10 equals negative 10k. So we divide it by negative 10 both sides. You will get k equals negative 1 over 10 natural log of 7 over 10. Check this k. No negative sign. So we need to move this negative sign as an exponent. We do know negative log base b of a equals log base b of 1 over a, or log base 1 over b of a. For 7 over 10, do the negative first power, that is 10 over 7. Therefore, 1 over 10 times natural log of 10 over 7 equals k. We finish proving. For C, find the temperature of the water when T equals 15. We already figured out the function for this temperature of water. T equals 100 e to the negative 1 over 10 natural log of 10 over 7 times T. Therefore, when T equals 15, this temperature equals 100 e to the negative 1 over 10 natural log of 10 over 7 times 15th power. We will put this into calculator. 100 times e to the negative 1 divided by 10. Natural log 10 divided by 7. Then times 15. Enter. Answer will be 58.6. So T equals 58.6 degree. Let's go to D. Sketch the graph of temperature T versus time T, clearly indicating any asymptotes with their equations and stating the coordinates of any points of intersection with the axis. Intersection with the axis basically means the x and the y-intercept. We know the y-intercept is 0, 100. There is no x-intercept because for this function, the horizontal asymptote line is y equals 0, which means no x-intercept. Let's go to graphing calculator. We will put the function into y1. You need to change the window. Time from 0 to 100. Scale is 10. Y minimum will be 0. Y maximum, let's do 100. Scale is 10. Then graph. You could see the graph like this. Now we can sketch the graph on the paper. Let's sketch this graph. This is a temperature. This is a time. Here, 0, 100. Then the curve will be like this, because this is an exponential equation. Don't forget the y equals 0 as a horizontal asymptote line. Let's go to E. Find the time taken for water to have a temperature of 50 degrees. Give your answer correct to the nearest second. For this function, we know T is 50 equals 100 e to the negative 1 over 10 times the natural log of 10 over 7 times t. We need to figure out this t. We will use the equation solver. So cross the river, change the sign. 0 equals 100 e negative 1 over 10 natural log 10 over 7t minus 50. Go to y equals. We put this function in already. Then minus 50. Go to math. Upper arrow, enter. Alpha trace, enter, enter. We will put 10 as a predicted value. Then alpha, enter. We will get answer 19.4335 and so on. So we pull this x out. Then 90 minutes. So I minus 19 times 60. This is seconds. So we have 90 minutes and 26 seconds, which means 19 minutes, 26 seconds. Then the temperature will drop to 50 degrees. Let's go to F. The model for the temperature of the water can also be expressed in the form T equals T sub O A to the T over 10th power for T greater than or equal to 0 and A is a positive constant. Find the exact value of A. We know this is the function for T, and also we know this is the facts. E to the natural log of x equals x. And e to the m times nth power, I can write down e to the mth power, then nth power. So we have a t sub o, e to the negative 1 over 10, natural log of 10 over 7. Then do the tth power. We will make a negative 1 over 10 jump as an exponent. So we have a t sub o, e to the natural log 10 over 7 to the negative 1 over 10th power, then to the tth power. T sub o, inside we will get 10 over 7 to the negative 1 over 10th power to the tth power. For this inside, 10 over 7 to the negative 1 over 10th power. Negative sign means negative 1. 10 over 7 to the negative 1th power means 7 over 10 to the 1 over 10th power. So we get t sub o, 7 over 10 to the 1 over 10th power, then to the tth power. Power of a power multiply. T sub o, 7 over 10th. 1 over 10 times t will be t over 10th power. So a equals 7 over 10.